This video will cover HVAC in OpenStudio. Energy Plus has a vast array of HVAC functions. In fact, if you look at the list of total objects that can be created, it's over half of the total objects available in Energy Plus. So here we'll just scratch the very surface of HVACs. You can see I've got a simple model here. It's a 5-space building with 2 thermal zones, and all the spaces are assigned to 1 story. Assigning spaces to a story will be helpful for running the scripts that we'll use later on in the video. You'll also need to make sure that you have your outdoor air objects specified, which were covered in another video, as well as infiltration objects. These will be used to determine how much air is brought in by the ventilation system and how much infiltration is occurring naturally. Let's go to the HVAC tab, which is the square feedback arrows. Often takes a few seconds for this to load. When you open it up, you should see something like this. Right now, we don't have any HVAC defined, so as we look in these different sections, we won't see anything. There are several types of HVAC systems that you can add in OpenStudio. If you look over here on the left, the plus sign gives you a summary of a range of template systems that we can use. So we've got packaged rooftop units, packaged rooftop heat pump, DXVAV with reheat, and some other variations here. These are all air loops up to this point. We can also put in an empty air loop. There are dual duct systems. Plant systems have to do with the circulation of water, and then a special type for service hot water. These roughly correspond to the ASHRAE 90.1 standard system types used for the baseline models as well. For the example, we'll just pick packaged rooftop unit. Don't do this yet. For our actual project, I'm going to recommend that you use a script that I'll demo later on in the video, but this will give you a sense of how to operate HVAC in general in OpenStudio. Click Add to Model, and it's built a system. This is the air loop. This is where outside air comes in, and this is where outside air is exhausted. The controller for that happens in this area. We've got a DX cooling coil, a gas heating coil, a fan, a node that is a type of controller, and a diffuser. So to complete this system, the only thing we need to do in order to make it functional is on the right-hand side under My Model, go to Thermal Zone, and add a thermal zone to the system. So now we have one thermal zone conditioned by this system. If we want to add another thermal zone, we'll drag it from the library, drop it down here, it'll put in another diffuser for us. And now we have a fully functional air loop. There are many things that we could do with this. Other objects we could add, such as ERVs. We could put in a heat pump coil. We could change the fan types. And if we click on each one of these items, then on the right-hand side, it exposes all of the settings behind that, and you can see that there are a vast array of settings to be made, from performance curves to other things like the COP, the airflow rate, which can be auto-sized or hard-sized if you have an actual design. Same with cooling capacity and many other things. I'm going to delete this air loop because we won't be using it and show you another item. OpenStudio also has the capability to model VRF systems, which are high-performance variable refrigerant flow, sometimes known as variable refrigerant volume systems. These are inverter-based systems. Mini splits are a variation on this type of system and can be modeled with these same tools here. Those function in a slightly different way, and so we come over to the VRF section on this pull down here, and then to put in a VRF system, we would go to the right-hand pane, go to Library, scroll down to VRF system. There's one available. Drag it and drop it out here. Now additional VRF systems can be downloaded from the building component library, including some specific manufacturer objects which have their custom performance curves and efficiency values and whatnot already input into them, which is incredibly valuable if you're using one of those systems. But if you're not, we're left with the generic objects. So if we go to the system now, click the magnifying glass with the plus sign, it blows it up. Now we can go to VRF terminal, drag in a terminal, and you can see it says drop thermal zone. So then you would go to My Model, because your thermal zones exist in your model. Scroll down until you find thermal zone. There it is. And I'll just put in thermal zone 1. So now we effectively have a single zone mini split or VRF type system. If I click on the system itself, in a moment, its properties will show up in the right-hand pane and can all be edited here. You can see, again, we have things that look similar to the cooling coil we looked at. There's a total cooling capacity that can be hard-sized if we know what that capacity is, or auto-sized. You input the COP to show the efficiency of the system, then input other general properties over here. It references all of the VRF performance curves. Same with heating capacity. You can either hard size it or auto size it. Put in the heating COP, and so on. There's a post on the website that gives rules of thumb for converting from different efficiency factors like HSPF, which is heating season performance factor, SEER, or SEER, which is seasonal energy efficiency ratio, energy efficiency ratio, and a few others, how to convert those to COP. If we click on the terminal, so the system would be the outdoor unit. The terminal, take a moment to load up here. There we go. Has the settings for the indoor unit. So we can either auto size or hard size things like supply airflow, outdoor airflow, and so forth. The operating schedule, characteristics of the fans, and so forth. And then, of course, the thermal zone is attached there. If I want to add another thermal zone, after I've made the settings I want in the terminal unit, I can just drop the next thermal zone on here, and it will replicate another terminal with the same values. Then if you click the magnifying glass with the subtraction sign, it takes you back to the main window, and I'm going to delete this one also, because we'll use another method here in our models. Now it's easier to do all this by using a script. The VRF systems are quite easy to set up manually, as I just demonstrated. However, if you have a large number of zones, it's nice if you can set those up automatically. The air loops are not as easy to deal with, and those are particularly nice to have a script to set up for you and get everything connected properly with the appropriate nodes and so forth. So the one that I'll recommend you use for our project where we're going for passive house level performance is going to be the VRF with DOAS measure. So I'm going to go to Apply Measure Now, save my model, and You'll find this on the building component library if you haven't already downloaded it, but it's under HVAC whole system, VRF with DOAS. VRF are the systems we just talked about with the variable refrigerant flow, and the DOAS is a dedicated outdoor air system. So it's going to replace any existing HVAC systems with the VRF and DOAS system. So as we scroll down here, you probably don't have any plenums, so that's not necessary. In my example, all of my spaces are conditioned. You would click all the spaces that are conditioned, and it will add VRF systems to the zones that those spaces are in. Any unconditioned spaces need to be in separate zones. So for example, a garage would need to be in a separate zone, and you wouldn't choose the space type that applies to the garage. The VRF condenser type will be air-cooled. The rated COP, I'd suggest using 5 for both the cooling and heating COP. This, of course, varies based on the actual equipment used, but that's a reasonable value to use for a fairly high performance but relatively attainable piece of equipment. The minimum outdoor air temperature in heat pump heating mode, this is fairly typical of the better performing equipment, that it can go down to about -4 degrees Fahrenheit. So I'd leave that like it is. Defrost strategy is fine. Heat pump waste heat recovery is a fantastic technology, but smaller systems typically don't have that. So unless you expect that you have it and might gain some advantage of being able to move heat from zones that are simultaneously experiencing heating and cooling in different parts of the building, then you would select no for that. There are some smaller residential scale systems on the market that will perform waste heat recovery, but they're considerably more costly than a conventional mini-split system, and there are limited applications in houses and buildings of that size for that type of technology. The next setting we want is DOAS energy recovery. You could choose yes, and it'll put in an energy recovery ventilator for you in here. However, the one it puts in via the script is not as efficient as what Passive House calls for. So I'll recommend that we insert it in a different way rather than having to go in and manually change all of the efficiency factors for that. The rest of the values are irrelevant because we're not putting in energy recovery, and the cost of the system isn't something we're trying to model either. So I'm going to apply the measure, and it tells me it started with 0 air loops, 0 plant loops, 0 zones conditioned. Now I have 1 air loop, still 0 plant loops, and 2 conditioned zones. So I'm going to accept those changes. And then let's look at our systems. Now if I pull down over here, the top of the list, I should see DOAS Building Story 1. Remember that it's essential for that script to have your spaces assigned to stories in OpenStudio, because that's how it applies the DOAS system, story by story. So each story gets its own dedicated outdoor air system. So I click on that. Put in this dedicated outdoor air system, so it's bringing in outdoor air here, and by default it's put in a DX cooling coil and a heating coil. In the systems we would be using in a passive house for a smaller building, typically wouldn't have these, so I'm going to delete both of those. The rest of the loop looks fine. Currently it's just bringing in outdoor air and blowing it directly into our zones via this fan and these diffusers. And remember, it's bringing in the quantity of outdoor air that was defined by your outdoor air objects that were associated with your space types. We would, however, since we're doing passive house, be using an energy recovery ventilator. to exchange the heat and moisture conditions of the outside air with the incoming air. So I need to go to my library, scroll down to heat exchanger, air-to-air sensible and latent. And we want the ERV heat exchanger. I'll grab that, and then I'm going to drag it over here onto these two nodes that bridge the outdoor air intake, and it places it there. And if I click on that, it shows me the properties of that ERV heat exchanger. And we can see the various different efficiency values are in the 70 to 80% range, which is in line with the Passive House requirements. So we'll accept all of those. The heat exchanger type doesn't particularly make any difference since the efficiency value is already defined for us. And we want to make sure that the economizer lockout is on yes, just in case you turn an economizer on. That wouldn't be a conventional technology to see in a house, but this will keep the ERV from running if you do turn on an economizer. So now we have a pretty good ERV dedicated outdoor air system that's serving both of the zones in the project. I'm going to go ahead and save my model. And now let's go look at our VRF system that was created for us. So I'm going to expand that by clicking here. Now it looks a lot like what we created manually before. But now you can see that the COP for cooling matches what our input was, as well as the COP for heating. It's going to auto-size the heating capacity and cooling capacity. The minimum outdoor temperature is -4 degrees. Our zone name for our master thermostat location. So this is going to be the zone that determines whether the system goes into heating mode or cooling mode. It's currently set to thermal zone 2. You can prioritize whichever one you think is more appropriate. I'm going to select thermal zone 1. Actually, I take it back. I'm going to select thermal zone 2 because that's where the bedrooms are. That would probably be the most important determinant in this building. We don't have waste heat recovery. There's some other settings that you can play with if you like that are particular to some of the different options with this type of system. But those are the major ones that we need to make sure are set properly. On the indoor units, the terminal is always going to be available, meaning that the system can run whenever the thermostat indicates it needs to. And we're going to auto-size all of our important values on those. Same on the other indoor unit. All right. The last thing we want to do, or next to last thing actually, is we want to go to thermal zones and make sure we have thermostat schedules applied to our zones. A lot of times you will have set these in the OpenStudio plugin, but if you haven't, then you can go to Schedule Rule Sets and scroll down to find your cooling thermostat schedule. Oops, I want to be under my model. I believe I've got one in here. No, it looks like I don't. I'm going to go back to my library. Looks like the best one I currently have available is medium office cooling set point and medium office heating set point. So let's go look at what those are. I dropped them on my thermostat schedule here. Go to my schedules, scroll down to find cooling set point. So it's set to 80 in the evenings. This is set up for an office, so when you're unoccupied, and 75 during the day. I believe the passive house values are 78 continuously. So I'm going to double click on the brakes and then enter 78 degrees Fahrenheit all the time, and I'm going to rename it, I'll call it pH cooling set point. So heating set point. This one, I believe, for passive house is 68 degrees Fahrenheit continuously. So I'm going to type in 68. Oops. Tab. No, it's not taking that for some reason. Manually adjust it to right at about 68. There we go. Now it's right on 68. Let me double check. Took the heating, cooling set point, and it did. All right, let me go back to my zones one more time. Oops, let me rename this. Under my thermal zones, now those are set. I like them, so I'm going to apply my cooling set point, then my heating set point to the other zone. Now in reality, I would probably want to set another schedule so that these two zones operated differently, and that's fine for the sake of your model, even though the passive house methodology, I don't believe, recommends that. But for your living space zone, you might let it drift into a wider zone at night when it's unoccupied, and the inverse for bedrooms, which are probably occupied at night, so they would be drifting during the day and then fully conditioned at night. You can play with the impact of those different kinds of strategies. All right, lastly, before we run the simulation, we'll go to settings. First of all, you can see I've got a pretty narrow run period here for testing, a 1-month run period. So just for the demonstration's sake, as I'm getting things set up and testing runs and troubleshooting, I usually keep it fairly short and then go the full year whenever I'm comfortable with the setup. One thing you want to make absolutely sure you do before you run the simulation with HVAC is go to Simulation Control. And if you're auto-sizing anything, you must turn on the zone sizing calculation. You must turn on the system sizing calculation. The model doesn't currently have any plant in it, but it doesn't hurt to go ahead and turn that on just so it's on. Once you put in your water heating system, then you'll have a plant in there as well. I'd recommend not running the simulation for sizing periods because it'll run for each design day before running the full simulation model, and you end up with confusing additional data in the front of your data set. Turn that off, and then you do want to run the simulation for weather file run periods. Save. We could go request any special variables we like. I'm going to turn on my OpenStudio results measure. So my results are packaged a little bit more nicely. Save. Then go to run. Then I'll click run. And there we have it. Our results. We'll pick up how to interpret your results in another model. This model wasn't built out with internal loads and other factors, so the EUI looks extraordinarily low. That's not realistic, but the process is. In the next video, we'll discuss how to interpret those results.